This video demonstrates how to analyze high CPU issues inside Erlang/OTP applications. Run the top command to check the CPU usage. As shown, this process consumes more than 200% of CPU cores. It is called ReBAR3. ReBAR3 is a tool for managing and building Erlang projects. Here, we use it to start the project. Let's run the ps command to see more details about this process. We can see it is the standard ReBAR3 binary executable shipped with the Linux distribution. Naturally, this program is also compiled using the Erlang, which comes with the standard distribution. Let's use OpenResty-Xray to check this unmodified process. You can analyze it in real time and figure out what is happening. Open the OpenResty-Xray web console in the web browser. Make sure it is the right machine you are watching. You can choose the right machine from the list below if the current one is not correct. Go to the guided analysis page. Here, you can see different types of problems that you can diagnose. Let's select high CPU usage. Click on Next. Select the Erlang application. Select the process that consumes almost 200% of CPU cores. This is what we saw previously in top. Make sure that the application type is right. Usually, the default should be correct. OpenResty-Xray can analyze multiple language levels at the same time. We'll keep both Erlang and C selected. We can also set the maximum analyzing time. We'll leave it as 300 seconds, which is the default value. Let's start analyzing. The system will keep performing different rounds of analysis. Now, it's executing the first round. The first round is done, and it's already on the second one. That's enough for this case. Let's stop analyzing. It automatically generated an analysis report. This is the type of problem we diagnose. It's CPU. Look at the number one hottest Erlang code path. Check response content function is a business function used to check the content of the response. It calls the filter function of the lists module to filter the list. The filter condition is an anonymous function that uses regular expression matching within itself. These calls all occur within the check response content function. Click to see more. This code path is automatically inferred from this Erlang LAN CPU flame graph. Here are more detailed explanations of the earlier code path. Go back to the previous hot code path. Hover the mouse over the green box for the first function. You can see the source file of this function in the tooltip. The Erlang source line number is 15. Click the icon to copy the source file path. Use the Vim editor to open this Erlang source file. You can use any editors you like. Go to line 15, as OpenResty-Xray suggested. This is the run function of the ER module. This is the lists filter function call we saw earlier in the report. This code path is indeed inside the check response content function. You can optimize this regex to avoid costly backtracking operations by the regex engine. Or consider using a non-backtracking regex engine. These two code paths are similar, and both of them execute regular matches. The third Erlang code path is calculating the length of the string. IList is the input string to be matched. And ERTS IList size is calculating the length of the string to be matched. The content is the input string to be matched. Switch back to the web console. Take a look at the C++ code path that takes up the most CPU time. The C++ language level analysis shows performance hotspots at the level of Erlang's Beam VM. The function match in PCRE performs regular matching. The second function ERTS PCRE execute is Erlang runtimes wrapper for the PCRE execute function in the PCRE library. A run function in the ER module of Erlang is used for executing regular expressions. This hexadecimal address indicates that this code path is executed in JIT compiled Erlang code. Go to the Insights page. You can find the reports on the Insights page for daily and weekly periods. For this reason, you don't have to use the guided analysis feature. Though guided analysis is useful for application development and demonstration purposes. OpenResty-Xray is a non-invasive diagnostic system based on our own dynamic tracing technology. It can monitor and scan performance problems, behavioral issues, and security vulnerabilities in real time. If you like this video, please subscribe to our YouTube channel. Thank you.